All right, hello again, everyone. Um, Hope you had a good weekend. I think this is after weekend. If it's not, just ignore that. I'm doing some of these videos in advance, so sometimes a little tricky to know. We're kind of approaching the idea of derivatives. So some of this stuff's going to be a little bit weird because you already done it, but we're going to have to backtrack. Pretend you didn't remember anything from the spring. I hope that's pretending for most of you. So today's lesson is rates of change and tangent lines. We'll then carry that over, into chapter 3 in derivatives. So we're going to go back to average rate of change, which I showed you in the first section. Average rate of change is just the change in y. Or we can think about it this way, right? Change in y over the change in x. There's all sorts of different ways you can notate that. F of x plus h minus f of x over h, blah, 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 blah. So I'm just going to use A and B for my 2 points, right? So A is my first x point, B is my second one. So change in y, if you remember slope from algebra 1, y2 minus y1 over x2 minus x1. Whenever you hear the term average rate of change in this class, you should be thinking slope. It's really, really important that you make those connections because we're going to interchange those terminology a lot. Okay, so our goal today is pretty simple. We're going to do a little calculus. You know how to find slope. You've done slope since algebra 1 or before. Get rid of that notation there. What we're going to look for today is slope of a tangent line at a certain point, right? So our idea here is this. I'm going to just draw a little graph, and we're going to look. Let's say I have a little point here. There's a tangent line here. We're going to try to find the slope of that little tangent line there. Okay, that's kind of our goal for today. And we're going to use a limit. Okay, so what we're going to do, I'm going to try to draw a quick explanation kind of why this works. But think about, you know what, I'm going to just use and start that over and draw another little picture real quick. We'll go green. So let's do this. So I'm going to use, I'm going to try to find the tangent line at this orange one, or the orange point. So the basic idea is this. I could find the slope between those 2 points. Okay. It's going to estimate that slope of the orange line. It's not going to be great, but it's going to estimate it. I can do even a little bit, might not seem better at first, but it will be better. Let me change the color. So we'll go, whoops, red here. I could also use that line. You're going to think that slope's not as good, which it's not for sure. Okay. However, if I just take this point here and start moving this point and continue to find those slopes, they're going to get closer and closer to the slope of the orange line. So we're going to use a limit. The basic idea is if this point gets closer and closer to that point, okay, then that red slope is getting closer to the orange slope. So that's kind of the idea. So our job here is to find the slope of the tangent line at a certain point. All right. And again, in a classroom, I might explain this a little differently, but it's a little tricky here. The idea is I'm using a little different notation, but the idea is basically what I just showed. So if I go down here and I call this A, oops. If I call this A, try that again, and this A plus H, as A plus H gets closer to A, which means H is getting closer to 0, right? That's the kind of idea of the limit. So this is my second point, that's my first point, and that's my H getting smaller and smaller and smaller. There's other notations which we'll show you. Let me get rid of this. There's the other notation, actually. So I'll just leave, actually, let's do this just for a second and keep this hidden from you. Sorry about that. So the slope m is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. A is just a value. It's a specific value. So sometimes, well, let's not use A. Let's just use x because that's more generic. So notice this next formula is the same formula. It just has an x in there in place of an A. It's the same formula. A is typically a number where x isn't, but it works both ways. And here's another one. This is, instead of using the idea of h getting smaller, you call one point x, you call one point c. So now you have f of x and f of c. Those are just the 2 points, and x is getting closer to c. It's just a different notation. It means exactly the same thing. You can use either notation you like. And we're going to do an example here in just a second. Okay. Just one little definition. You might hear this word normal line. Normal line is a line that's perpendicular to the tangent line. So the typical question would look like this, which we'll do here in just a second. Find the equation of a tangent line to a certain curve at a point. I just said find the equation of the normal line, so I would need to use perpendicular. So we'll do that one second. So let's do this. So let's just say tangent first, right? We're going to come down here. We're going to get rid of this picture. We're just going to walk you through one example and I'll be done. If you remember how to do this, it's just the basic of practicing a limit problem, but it's actually not just practicing a limit problem, it's actually telling you some meaning, right? So our definition here is limit as h approaches 0. I'm going to use this one. This is my favorite one. F of x plus h minus f of x all over h. Now you have a choice. If you want to put that 1 in for x right now, you can do it. I'm never going to do that, okay? Because the next problem they might say at 1 and at 2 and at 3. You don't want to do them all, right? So I'm just going to do it with x in there. And then when I'm done, I just put my value in for x that I'm given in this problem, which is the 1, right? So now I'm going to change colors so this looks a little different. So we're going to go limit as h approaches 0. F of x plus h just means take that x plus h and plug it into my function, right? So it's going to be 4 minus x plus h squared. So that's my f of x plus h minus f of x, which is just the function. Be careful here with this parentheses. It's really easy to drop parentheses. 4 minus x squared. So f of x plus h minus f of x all over h. Just a limit problem. All right. So if we did what we did in the first section with limits, remember the idea is just plug that 0 in. Well, if I just plug that 0 in, what's going to happen is I'm going to get, whoops, different color here. I'm going to get, if h is 0, this would be 4 minus x squared plus x squared. Okay, minus 4. So sorry, it would be 4 minus x squared. If that h is 0, minus 4 plus x squared over 0. You get 0 over 0. Doesn't help you at all. It means you got to simplify, reduce, factor, whatever, right? So that's what we're going to do. So we're going to come back to the steps here. We're going to multiply this out. X squared plus 2xh plus h squared. So I'm going to multiply that out. Minus the 4 minus x squared. Just doing some algebra right now. A lot of algebra in this class, by the way. Calculus actually is not too hard, but there's a lot of heavy-duty algebra in it. So now I get 4 minus x squared minus 2xh minus h squared minus 4 plus x squared all over h. Do a little simplifying on that top. Let's see, the 4's cancel, 4 minus 4. Negative x squared, positive x squared cancels. And I'm left with negative 2xh minus h squared all over h. If you've done it right, there's going to be a lot of problems like this. If you've done it right, there should be no x terms left. We need to plug in that h to 0. The x's need to reduce out, basically. So now, if I plug in the 0, notice it's still 0 minus 0 over 0. It's still 0 over 0. However, I can do a little factoring here, and we can go limit as h approaches 0. If I just factor out a negative h or an h, it doesn't matter which one, actually. Let's just factor out an h. If I factor out an h, what's left is negative 2x minus h all over h. H's cancel. And now I get limit as h approaches 0 of negative 2x minus h. Plug in the 0, and I get negative 2x. So that's the answer to that limit question. But remember the original problem, back all the way to here, was to find the equation of the tangent or normal line, which in a second, at x equals 1. So I come back to here, and I go when x equals 1, slope, because remember all of this was slope, right? I didn't really write it, slope. slope. The slope equals -2. Now I have the slope of the tangent line. I did ask for the equation. Remember, not just the slope. So I asked for the equation at x equals 1. So if x equals 1, we're just going to find y by coming back here and plugging into my original function right here, which is 4 minus 1, which is 3. So now I got the slope and a point. Remember, some point slope form from algebra 1. Y minus 3 equals -2 times x minus 1. If no one asks you or says anything, they just say find the equation of a line, any form you want. Point slope form's easiest, done. I know back in algebra 1, you probably were forced to put everything in y equals mx plus b form. That's just an exercise in algebra. We don't need to worry about that in this class. All right, so that was the tangent line. Remember, the original problem actually said normal line. So normal line just means instead of the slope being -1/2, it's opposite reciprocal. Opposite reciprocal, hopefully remember that from algebra 1. So we're just going to go y minus 3 equals 1/2. Opposite reciprocal, x minus 1. This would be the normal line. So a little practice in limits, practice in algebra. We'll carry this idea into chapter 3, into derivatives, which you may remember anyway. So that's it for section 2.4. Let me know if you have any questions. Thanks.